Okay, so now we've got more to talk about. We have all the negation rules. So there's 3 rules for negation. The first one is negation elimination, which tells you that if you have P and you have not P, where P is any formula, so if you have 2 things that contradict each other, then you can obtain false. Okay? Which means from a contradiction you can prove false things, which makes sense. Negation introduction says that suppose you want to prove not P, you can do that by assuming P to be true, so assume the opposite of what you want, do some stuff, and obtain false, therefore not P. And PC, proof by contradiction, is almost the same thing, but it's for removing a negation instead of adding one. So suppose you wanted to prove P, how you can do that is you can assume the opposite. You can assume not P, do some stuff, and obtain false, therefore P. So let's have a look at how we can use these examples to prove some theorems. So I want to prove if P is true, then not P is true. So this is called like the double negation rule. So we formulate our proof like normal. We write our goal down the bottom. P implies not P. Okay? This is an implication, and we know how to prove implications. We assume the left and derive the right. So I'm going to do that. Assume the left and derive the right. Okay? This stage here, it's not so obvious how to obtain not P from P. So if you're stuck, sometimes you can try assuming the opposite and then get what you need. So I know that if I drop a negation and assume it to be true and obtain false, then I can prove that not P is true. So similarly, if I assume not P to be true and somehow obtain false, then the negation of this is true. The negation of not P is not P. Okay? So how can we fill in the gap? Well, I've got P here and I've got not P here, therefore I can obtain false by negation elimination. Okay? So the gap is filled, the proof is done. Let's put our line numbers, let's put our rules. This is an assumption, this is an assumption, this is negation elimination by lines 1 and 2 because these 2 statements contradict each other. I assumed not P to be true, I obtained false, therefore not P by negation introduction, right? If you assume it to be true and it was false, you can add a negation for free. So this is negation introduction, lines 2 through 3. You quote the entire block. And this is just standard implication introduction. I assume P, I derive not P, therefore P implies not P. Implication introduction, lines 1 through 4.